Electron mass. Juan Rodriguez. Introduction. Juan Rodriguez, Roman Hernandez. Electron mass. Electron mass is a fundamental property of its tiny subatomic particle carrying a negative electric charge. The electron mass is a cornerstone in our understanding of the microscopic world and has far-reaching implications across fundamental science and technological innovations. J.J. Thomson and Robert A. Milken are the most relevant scientists in the original experiment. Impact original. The original experimental determination of the electron mass relied on the combination of Thomson's measurement of the charge to the mass ratio and Millikan's measurement of the elementary charge. Initial determination of the electron mass was a two-step process. J.J. Thomson first measured the electron's charge to mass ratio using a cathode ray tube. Later, Robert Milken determined the elementary charge through his oil drop experiment. The motivation behind the experiment to determine the electron's mass stemmed from a desire to understand the fundamental nature of matter and electricity to build a more accurate model of the atom. The original discovery and the determination of the electron mass were not just isolated scientific findings. They were pivotal moments that fundamentally altered our understanding of the matter. Impact modern. Modern experiments for determining the electron mass rely on trapping single ions and pinning traps and performing ultra precise measurement of the cyclotron frequencies by conducting high resolution atomic spectroscope on simple atomic systems. The modern approach to determining the electron mass is characterized by direct or near direct measurements on single particles or atoms use likely advanced technology and theoretical frameworks like QED, leading to vastly improved precision compared to the original indirect methods. The benefits extend from most fundamental theory of physics to practical applications that impact our daily lives. The future of electron mass research promises continued advance in the precision measurement techniques driven by the quest to test the limits of our current understanding of physics and potential uncover new phenomena beyond the standard model. Relevance of question to topic explained. The question, how was the mass of the electrons first determined and how has the precision of that measurement improved over time, and directly relevant to atomic physics and fundamental particle research. Understanding electron mass is critical because it is a fundamental constant that affects atomic structure, chemical reactions, and modern technologies like semiconductors and particle accelerations. Benefits of understanding questions given. Understand how electron mass was first measured, e.g. through J.J. Thomson's charge to mass ratio experiments and Robert Milken's oil drop experiment. Gives insight to experimental techniques and the evolution of scientific precision. It also highlights how improvements in technology and theory allow scientists to refine fundamental constants, which are the foundation for advanced research and applications. Process of writing questions outlined. The question was developed by reviewing key milestones in the discovery and measurement of some subatomic particles after studying historical experiments and recent advancements in the quantum mechanics and particle physics. It becomes clear that tracking the development of precision and electron mass measurement would connect historical, and modern scientific methods. Uniqueness of questions discussed. How many questions focus on the discovery of electrons itself? Few concentrate on how its mass was measured and refined. This angle encourages a deeper explanation of experimental physics and the challenges scientists faced in improving accuracy over time, make it a unique and valuable questions for understanding the growth of scientific knowledge.
Millikan's oil drop experiment diagram. Several thousand volts, oil spray, cover, microscope, uniform electric field. Relevant formulas, constants explained, key formulas, force balance, QE equals mg, Q is the charge on the droplet, E is the electric field strength, M is the mass of the droplet, G is the gravitational acceleration, 9.8 m per s. Milken measured Q and using Thomson's earlier EM ratio, charge to mass ratio, he calculated the mass of the electrons, Me equals E divided by EM. Constants, E elementary charge equals 1.602 times 10 to the negative 19th. EM from Thomson equals 1.578820 times 10 to 11 CKG. Solving process thoroughly described. Milkins measured the electrical field needed to suspend a droplet, balanced electric and gravitational force. By knowing the droplet radius and density, he calculated the droplet mass. He observed the charge was always a multiple of fundamental value, confirming the quantization of electrical charge. With elementary charge E known, and then in the EM ratio from Thomson experiment, he solved for electron's mass. Me equals E divided by EM equals 1.602 times 10 to the 19 divided by 1.758820 times 10 to the 11th equals 9.109 times 10 to the negative 31 kilograms. Solution correct, applicable to topic. The calculation correctly determines that electrons' mass directly tied to fundamental physics and the development of atomic models. It shows the importance of experimental methods in physics and demonstrates how scientists determine constants crucial for science and technology. Addition of valuable information provided. The precise measurements of the electron's mass not only helped confirm the structure of the atom, but also led to advancement in quantum mechanics and modern technology. Knowing the electron mass accurately is important for fields like chemistry, materials science, and electronics. Improvements in methods like pinning traps has allowed scientists to determine the electron mass with great precision today. Addition of students' interest. Learning about the electron mass is fascinating because it shows how tiny discoveries can make massive impacts on science and technology. Measuring something as small and invisible as an electron requires incredible creativity and precision. It is cool to see how early experiments like Thomson and Milken laid the foundation for everything. Overall summary of topic presented. The electron's mass was first roughly estimated through early cathode ray experiments and precisely measured by Robert Milken's oil drop experiment. Using J.J. Thomson's earlier work on the charge to mass ratio, over the past century, experimental techniques have greatly improved to precision of these measurements, depending our understanding of matter and enabling technological revelation. Relevant source: Milken's R.A. 1913 on the elementary electric charge and the Avogadro constant. Thomson J.J. 1897 cathode rays. Kodak International recommended values of the fundamental physics constant 2022. Tipler, PA, and Mosca G, 2008, Physics for Scientists and Engineers. Griffiths, DJ, 2017, Introduction to Electrodynamics.